In this video, we're going to learn about a turbidity sensor. We'll learn about what it does, how it works, and the basics of how to use it. If you've got a JackBord, you can also use this video with the JackBord. And if there are any differences, we'll let you know. For this video, you're going to need a JackBord Basic, a USB-C cable, a PC or a Chromebook, the Google Chrome web browser or the Microsoft Edge web browser, a turbidity sensor, 3 jumper wires, female to female, 1 M4 bolt and 1 M4 nut, and a spanner. Turbidity is a measure of the cloudiness of a fluid caused by large numbers of individual particles that are generally invisible to the naked eye, similar to smoke or dust in the air. So for example, when you look at smoke, while you can see the smoke cloud overall, if you zoomed right in, you wouldn't be able to see one particular smoke particle. And so the measurement of turbidity is a key test of water quality. Obviously no one likes it when you turn on the tap and you have cloudy water come out of it. And because the particles scatter and absorb light, the more particles present in the water, the higher the turbidity. And the result makes the liquid appear cloudy or murky. The chart at the bottom of the screen shows some examples of what certain turbidities would look like. So on the far left we've got a very low turbidity, and that's because the water doesn't look all that cloudy. A little bit cloudy, but not very cloudy. Whereas on the right hand side you have the other extreme, which is a high turbidity, and you have no hope of even being able to see through the water. And so that's a very high turbidity. And so essentially the sample on the right hand side has a lot of these small particles suspended in the water. In this picture we can see a turbidity sensor. So first of all, we have on this side the universal sensor interface, which is what allows you to connect it to the JackBord. We have the cable that links the sensor to the USI. And then finally down here, this is the sensor that actually measures the turbidity, and this is what goes in the water. Okay, so this is the turbidity sensor here, and this is what goes in the water, which is why it's all waterproof and sealed up. And then you've got the sensor end over here. And you've got the cable, and this is the USI that will ultimately connect to the JackBord Basic. So here we have the turbidity sensor that we just saw before, and you notice that it's got 2 prongs on it. And if we remove the cover and we look inside, you have on the left hand side an infrared transmitter that sends out an infrared beam just like your TV remote control. And that goes across a gap here and over to an infrared receiver or an infrared sensor. And then in the sensor itself you have a gap, which is this area here, through which water can pass. So the material that you're measuring actually fills this gap or fills this area here. And basically what the sensor is looking at is how much of the light, the infrared light that it's sent, ends up arriving at the infrared sensor. If it all arrives, that means that there's nothing here. Whatever material there is completely clear and it has a very, very low turbidity. On the other hand, if none of the light got to the other side, that would mean that the material had a very, very high turbidity because you can't see through it. And by definition, to see through something, you look at it with light. And so if you can't see any light through it, then it has a very high turbidity. So the turbidity sensor works by detecting how much of an infrared beam is blocked by the material that you're measuring. And the higher the turbidity, the higher the blockage of the infrared energy there is. The turbidity sensor itself has 3 pins on the USI. You've got the yellow 3-volt pin, green ground pin, and the blue voltage out pin. Now the voltage out pin is essentially the way that you get the reading from the turbidity sensor. And what we'll see later on is you see a voltage on this pin that is directly proportional to the turbidity of the substance that you're measuring. So once again, if we look at the voltage, on the USI you had the blue voltage output pin. And essentially, if the water is very, very clear and the turbidity is very low, the output voltage will be around about 2.8 volts because you get some variation between sensors. On the other hand, if the turbidity is very high or the water is very dirty, the output voltage will be around about 0 volts. and then somewhere in the middle will be about 1.4 volts or 1.2 volts, something like that. So essentially the output voltage from the sensor is directly proportional to the turbidity of the water. Okay, I've got a turbidity sensor here, and it's connected to the JackBord Basic just to get power, so it's only getting power. And then I'm using a digital multimeter over here to measure the voltage that's coming out of the turbidity sensor. And so right now you can see it's about 2.57 volts, and that's because there's no material between the sensors, which are these two here, and effectively the turbidity is 0, so it's very, very clear. And then if I was to take something like this bag, and if I was to put it in, you can see the value goes down to about 2.4 volts. So you can't see through the bag, but the turbidity is not that high. But then if I was to double it over like this, you can see the turbidity's gone a lot higher, so it's about 1.4. So as the infrared light finds it more and more difficult to penetrate, the turbidity gets higher. So if I put this in, this is 4 layers, goes down to about half a volt. So this is a measure of the turbidity. So you can see it's not 0, even though we can't see through this, the turbidity itself is not 0 yet. Another example is if I take a sheet of paper and I put it in the sensor. So it's about 0.6 of a volt. Take it out, it goes back to 2.5, so it's about 0.8 or 0.6. And then finally, if I take a piece of card which will block all of the light, so that's very, very high turbidity, you can see the reading goes down to about 0 volts, effectively 0 volts. So 0.07 of a volt. And that's very, very high turbidity, and as you can see, there's no light or anything that's going to get through there. So once again, you have the transmitter on one side and the receiver on the other side, and the sensor is looking at how much infrared light can get through between the two parts. The reason they use infrared light instead of visible light is that if you were to use visible light, then you would end up detecting lights in the room, you detect the sun, you detect all sorts of things. So they use infrared, which you can't see, and it gives much better readings. So next we're going to connect the sensor to the JackBord Basic. So this is the sensor itself, and then this is port B on the Basic, and you can see it over here as well. And essentially we have 3 jumper wires to connect. One is the 3 volt power, the second one is the ground, and then the third one is the voltage output, which we're going to take from the blue pin on the sensor to port pin B1 on the JackBord Basic. And essentially you need to bolt the sensor onto port B, as that's basically the most convenient place to put it. So to connect the turbidity sensor to the JackBord Basic, first thing you do is just take the M4 nut and bolt it above port B like this, and then you just use the spanner to tighten it. Then in terms of connecting the pins, the first one we want is the ground. So we're going to go from the ground, or the G pin on port B, over to the green pins on the turbidity sensor. And the next one is the 3 volts power. So we go from 3 volts on the port B over to the 3 volts on the turbidity sensor. And then finally we need to get the voltage output from the sensor into the JackBord. So we're going to go from the blue pin on the sensor to port pin B1. So we're going to use B1 on port B. And that's our connection. So essentially we have 3 volts power going from port B over to the sensor, ground going to the sensor, and then finally port pin B1 going to the voltage out pin on the sensor. And bolt the sensor above port B, because that's a very simple way to mount it. And notice that I've done it while the JackBord Basics disconnected from the PC as well, so there's no power. Okay, and once you've made your connections, check them against these pictures to make sure that everything's connected okay. Now that we've done the physical connections to the JackBord Basic, we want to start measuring the voltage that's coming out of port pin B1. And to do this, you simply use the GAV, which is get analog voltage space B1, because we want to read the voltage from pin B1. And then subsequently, you can use the GT command to see what the voltage values are. Okay, we've got the turbidity sensor here, and it's connected to the JackBord Basic, and the Basic's all turned on. So first of all, we want to get the analog voltage out of the JackBord Basic. So we go GAV space B1, and that sets up the basic to give us the voltage readings from port B1. Now to get the actual reading, we can use the GT command, but because we only want the reading from the port pin B1, we go GT B1. And so what that does is it just gives us the reading from port pin B1. And so it's 2.6 volts, which is about as expected. So now if I get the material we had before, this is the bag, and I get another reading, it's still about 2.6. Yeah, so it's not very high. And then if I double it over, so we've got twice the material, we get another reading, and sure enough it goes down to about 1.4. So that's the turbidity increasing because less of the infrared energy can get through the material. And then likewise, if I put this piece of paper on, yeah, and it goes down to 0.7. Then finally, if I get this piece of card, which represents like zero light getting through or zero infrared getting through, and sure enough, the reading's 0 volts. So that's a turbidity which is very, very high, because there's no infrared energy able to pass through. So to summarize, turbidity is a measure of the cloudiness of a fluid. The turbidity sensor uses an infrared beam to measure the amount of light that passes between the two probes. And the greater the turbidity or cloudiness of the water, less of that light gets through. And then finally, the sensor puts out a voltage between about 2.6 for the minimum turbidity, or very clean water, and goes down to 0 volts for very dirty water with a very high turbidity. One of the things you can do next is to figure out how to scale the readings of turbidity between 0 and 100, where 100 is the maximum turbidity. And some of the videos from the series on sensors for the JackBord Basic might help with that. And then adapt the light meter code from one of the videos in that series, and you just search the TMT code show to find it, to display the readings from the turbidity sensor using a gauge. And then you can use your turbidity sensor to just measure the turbidity of different things around your house, like different types of drink, maybe Coca-Cola, maybe coffee, tea, and dirty water, etc., and then see how they compare. For more information and to get help, visit jb.works.